Good morning and welcome to the world of conic sections. Today we're doing Chapter 10, Section 4, Hyperbolas. Please pause the video at this time to copy down the information. Find the center, vertices, foci, and the equations of the asymptotes. Sketch the graph. Well, a reminder that to find our missing values, either a, b, or c, we're going to use the equation a squared plus b squared equals c squared. From our problem, we know that a equals 3 and b equals 5 because this is a horizontal hyperbola. Because there is no h and k, we know the center is at 0, 0. Since we also know that it's horizontal, we know the vertices are going to change by a, and that's the x that's going to change by a. So that's the vertices is plus or minus 3, 0. And we need to find the foci. To find the foci, we need c. Well, to do c, we need to find 9 plus 25 is equal to c squared. That's a squared plus b squared equals c squared. So that's 34 equals c squared, or c equals the square root of 34. So my foci, again, it's the x that's changing, so that's plus or minus the square root of 34 and 0. And my asymptotes are going to be y equals b over a, 5/3, x, plus or minus. Okay, now we're ready to graph our asymptote. We can graph our center, we know, as at 0, 0. We know our foci are plus or minus the square root of 34, which we know is close to 6. So about right here and about right here. Those are our foci. The vertices are at plus or minus 3 here and here. And we know because b is 5, we know we can go up 5, 1, and down 5. Okay, now the easiest way to graph our asymptotes is to make a little box using the vertices. So we're going to make a little box using the vertices. And we know the asymptotes are going to be the diagonals of that rectangular box. So there's our asymptotes. Then we know our hyperbola starts at the vertex and goes as quickly as it can towards the asymptote. And that happens on both sides. And that's how you graph a hyperbola with center at 0, 0. Before we can graph this hyperbola, we have to complete the square. Then we will find the information like we did previously, the center, the vertices, foci, and the asymptotes. So let's set it up. That's going to be x squared. And there's nothing that's attached with the x squared. There are no x's, so it's already completed. We now need to work with the y. So that's 9y squared plus 36y. And we add 72 to the other side, and we're all ready to go. Like we said, the x is done. So that's x squared. Now, in the y's, I need to take out negative 9, and that leaves me with y squared minus 4y is equal to 72. Okay, the missing part is going to be half of 4, which is 2 squared, so I'm going to add 4. But I know what I'm really adding is negative 9 times 4, which is negative 36. So I have to add negative 36 to the other side. So that gives me x squared minus 9 times x minus 2 squared equals 36. Well, we know all hyperbola equations equal 1. So that means I need to divide everything by 36. So that's x squared over 36 minus x minus 2 squared over 4 equals 1. There's my equation, and now I'm going to pull out the center, the vertices, the foci, and the asymptote. Okay, now we're ready to find the center. The center is 0, 2. That's our h and k. Now, we also know that A equals 6 and B equals 2. Our vertices are changing on the x because this is a horizontal hyperbola, so that's going to be plus or minus 6, comma 2. Okay? Our foci also changes the x variable, and our foci we're going to find to be 36 plus 4 equals c squared. So 40 equals c squared. C equals the square root of 40. So our foci is plus or minus 40 square root of 40, comma 2. And our asymptote is going to be y equals 2 plus or minus 1/3 x. We're going to start by graphing all the points we know. We know the center is at 0, 2. We know that the vertices are at plus or minus 6, 1, 2, 3, 4, 6, 2, and negative 6, 2. We know our foci is at 40, which is just a little bit more than 6, but not quite 7. So right in there, and right in there. And we know our B is going to be up 2 and down 2. So up 2 is going to be up here, and down 2 is going to be down here. Okay, we draw our little rectangle that we have. And then we can draw our asymptotes, which again are the diagonals of the rectangle. Okay. Then our hyperbola is using the vertex and going as quickly as we can to the asymptotes. And there's how we graph a parabola, or excuse me, a hyperbola. Now we're going to find the standard form of the equation of the hyperbola with the center at the origin. Well, if the center's at the origin, and we see our vertices are plus or minus 4, 0, and our foci is plus or minus 6, we already know what A and B are. And we need to find, or A and C are, and we need to find B. So we've got A squared, which is 16, plus B squared, which is equal to C squared, which is 36. So that makes B squared equal to 20. Okay, we really don't need to find B because B squared is what we use in our equation. And our standard form with the origin being the center is x squared over a squared minus y squared over b squared equals 1. We know we're using this form because we've already determined that this is a horizontal hyperbola. Since we know what A is, we know A squared is 16, and we know B squared is 20, and we know that's equal to 1. And there's our standard form of an equation with the given information. We're going to find the standard form of an equation for a hyperbola with a little bit different information, with the foci and asymptotes. Well, we know if we have a foci, we know that C equals 10. And since we have our equation for our asymptote as y equals plus or minus 3 over 4 times x, because the foci tells us it's a horizontal, we know that our slope here is b over a. And we know that the ratio of b to a is 3 over 4, but we're not sure if there is a multiple. So we're going to put a variable in here and see if there is a multiple that is going to multiply times that. Well, we know a squared plus b squared equals c squared, so that's 100 equals 3m squared, what we said b was, plus 4m squared, what we said a was. So that gives me 100 equals, that's 9m squared, and that's 16m squared, so that's 25m squared, and m squared equals 4 when I divide both sides by 25. So that means m equals 2. So that means my ratio, that gives me what my A is going to be. A is going to be equal to 4 times 2, or 8, and B is going to be equal to 3 times 2, which is 6. So now I'm ready to write my equation. X squared over A squared, 64, minus Y squared over B squared, which is 36, all equals 1. And there's my standard form of my equation. Okay, as we look at the information here, we're trying to find the standard form of the equation of the hyperbola, with our vertices at 2, 3, 2, negative 3, our foci at 2, 6, and 2, negative 6. We notice it's the y's that are changing this time, so we're going to have a vertical hyperbola. Now, we know that the center is going to be halfway between the two vertices. So my center is going to be at 2, 0. Okay, like we said, it is the y's that are changing, so it is a vertical. So I know that A is 3, because that's the changes from center, so A equals 3, And C changes where C is equal to 6. Well, then I know that 9 plus b squared equals 36. And b squared equals 27. Okay, I don't need to find b because all I'm going to be using in the equation is b squared. Okay, so I plug in my h and k, so y minus 0 squared over a squared, 9, minus x minus 2 squared over 27 equals 1. We know the y came first because we already determined it was a vertical hyperbola. Simplify that out a little bit. Y squared over 9 minus x minus 2 squared over 27 equals 1. And we're finished. This is all for the conic sections. The next thing we'll be doing is rotating the conic sections. Tune back later. See you.